Hello, everyone. This is Tim Eifler from the University of Arizona, and I'll be talking about Rubin synergies today. If you would like to know more details about the so-called Roman-wide concept, please have a look at this paper. And if you're interested in learning about Roman high latitude reference survey concept and multiprobe strategies therein, please have a look at this paper. So just in terms of terminology, the reference survey corresponds to the more widely known 2000 square degree survey, 4 different bands, very deep. The Roman-wide survey is an idea to use just one band and cover the entire LSST area to LSST year 10 depth. Very quickly, the latest news on the Roman Space Telescope. So it has entered phase C, so NASA considers it now a real mission. There's hardware being built. The project is on schedule for an October 25 launch. COVID has impacted the schedule a little bit, but not so much as one might have feared. There's been lots of work going on with the hardware. So the primary mirror has been reconfigured. The 7 infrared detectors have passed acceptance, and production testing for these has actually restarted. Very excitingly, there's new slew times. So with all 6 reaction wheels operating, the slew time has significantly decreased. For a 2-degree slew, this is improved from 130 seconds down to just 99 seconds. And given that there is more than 100,000 slews per year, this actually adds up to quite a significant improvement in observing time and speed. So everything that I'm going to present in this overview is actually still calculated with the old slew time. So you can imagine that there has been a significant improvement to everything that I'm going to show in the following slides. Very briefly, this slide is on the Roman Space Telescope capabilities. So here you can see telescope aperture, field of view, pixel scale, wavelength range. And I want to highlight mostly the imaging capabilities. You can see down here the corresponding properties for GRISM and PRISM, but here we have the 4 bands that are being used in the reference survey, YJHF. And I also would like to highlight the W band, which is significantly broader, from 0.93 microns to 2 microns. This obviously enables the Roman Space Telescope to observe with much higher speed than if it were to observe in these 4 bands. So the Roman-wide survey concept is the idea to cover all of LSST area, so let's say 18,000 square degrees, with the W band, with this very wide band. And this graph on in this figure shows how fast the Roman Space Telescope can actually achieve a depth over the entire LSST area to the relevant LSST depth. So this sample, this galaxy sample here, corresponds to the LSST gold sample. And after just 5 months, the Roman Space Telescope can achieve 95% completeness of the LSST year 10 gold sample. And that is, again, over the entire LSST area. If one were to conduct such a survey for 1 year, that would cover the entire sky to this corresponding depth. One disclaimer, of course, a W band is more easily affected by systematics. Wavelength-dependent PSF are an issue for Euclid, for the Euclid satellite mission as well, and a similar impact would also happen. Comparable impact actually would also affect the Roman Space Telescope. But given that it's just 5 months of a survey, there's actually remaining time in the high latitude survey that can be used for a deep multiband photometry survey with the 4 bands that were originally thought of to be used in the reference survey. So one could still do of order 1500 square degrees with the 4 bands, and that gives you a lot of opportunities for calibrating the much larger W band survey. So the idea of the Roman-wide survey is to synergize with Rubin, of course. So Rubin observing bands can be seen here on the left. You can see that they reach 1 micron quite easily. And here on the right, you can see the Roman Space Telescope bands. Again, YJ, H, and W, YJ, H, and F are the ones that are being used for the reference survey. And this could still be done also in the wide survey concept. But the wide survey concept would rely on this W band, which goes down to 0.93 arc minutes. So the idea would be to combine this wide survey with the W band and the 6 LSST bands for photometric calibration, and then have additional calibration by a smaller area that is being covered in the 4 bands with Roman Space Telescope. We ran this scenario through some forecasting machinery. So we used the exposure time calculator to create a realistic survey scenario, and so area and depth. We got redshift distribution from the candles catalog. That is, of course, somewhat affected by sample variance. We got we chose probes, scales, redshifts. We calculated a multi-probe covariance matrix and ran a sophisticated simulated likelihood analysis, factoring in the desk science requirement document analysis choices when we were looking at the joint Roman and LSST science return. So results can be found here in these papers. And yeah, if you're interested in the figure of merit, we've basically shown that we increased the figure of merit for a Roman wide plus Rubin concept by a factor of 5.5 over the Roman reference survey only. And that is including 56 dimension, including systematic sphere calibration, galaxy bias, photo-Z, intrinsic alignment, and baryons. There are, of course, synergies beyond just dark energy. So this concept is interesting for cosmology in general, of course, but also beyond the joint weak lensing and galaxy clustering analysis. This is interesting for galaxy cluster science. So a wide survey will increase the cluster sample that we observe, will increase also important cluster systematics like weak lensing mass calibration, deep blending, photo-Z calibration. Within Rubin Observatory, we can't do as good a job as if we have space-based coverage. Trough cosmology, and also in particular Trough lensing, is a really interesting probe for dark energy. If we have coverage over the entire LSST area with space-based observations in the W band, we'll be able to more precisely characterize the Trough boundaries. We will get a higher number density of background lenses, and generally we will have a larger sample size for troughs. Strong lensing, the Roman wide idea will improve lens profile characterization. There are also benefits for stellar and galactic astronomy. So Roman wide will improve stellar stream tracing, brown dwarfs, cold white dwarf, and AGB star detection. There are interesting synergies between CMB Observatory, so Simon's Observatory, CMB S4, and the joint Roman and Rubin observation over the 18,000 square degrees. So this will boost CMB lensing, KSC and TSC signals, and it will enable multiple systematic self-calibration strategies. So to summarize, the Roman wide survey concept can cover the LSST area to LSST year 10 gold sample depth in only 5 months, in less than 5 months even, given the new slewing times. The wide concept still leaves time to conduct a large, roughly 1500 square degree 4-band extragalactic survey to the depth of the current reference survey, and that can be used for further calibration of the area that's otherwise observed in the wide band only, in the W band only. Roman wide plus Rubin enables multiple synergies for dark energy, cosmology, and broader astronomy science. And in particular, this would be very useful for systematics mitigation strategies that LSST will have to implement. I would like to iterate once again that the Roman observing strategy is not yet defined. This will be defined shortly before launch, or it will be finalized shortly before launch. So community input is very important for this, because we would like to define a mission that benefits all science cases and communities. So please keep giving input into defining the Roman observing strategy and think about what a wide concept could do for your science area. Thank you.